Hello, students. How are you? I hope everyone is doing well. In our previous classes, we have discussed the numericals from current electricity. In today's class, we are going to solve the numericals from exercise 10C of electromagnetism in a simple and easy way. So, let's start. This is our first question. The magnetic flux through a coil having 100 turns decreases from 5 milliweber to 0 in 5 seconds. Calculate the EMF induced in the coil. Let's find what is given in the question first. There are 100 turns. I will write it is equal to n number of turns, capital N. And this is the flux it is when 5 milliampere is initial flux and the final flux is 0 equal to 0. Time is given 5 seconds. Time is 5 seconds. So what we have to find in this question, EMF induced in the coil. So we have a formula, epsilon equal to minus n delta pi by delta t. Delta pi can be written as pi 2 minus pi 1. This is 0 and pi 1 is 5 milliampere. Milliweber. 5 milliweber. So convert into milliweber, just you will get pi into 0.001 Weber. That equal to minus 0.005 Weber. Time delta t equal to t2 minus t1. Time difference given in the question is 5 seconds. So directly take into the equation now. So epsilon equal to minus 10 into pi value is delta pi value as of 0.005 divided by 5. Epsilon equal to minus into minus plus 0.5 by epsilon equal. So 0.1 volt you will get it. 1 volt. Okay, we will write there is a one more form here like epsilon equal, right? Both are correct. No issue. The next question, transformer has 800 turns and the secondary coil has 8 turns. It is connected to 220 volt AC supply. What will be the output voltage? So this is step down transformer. Step down transformer, and let me see what is given here. Output voltage need to find. This is the input number of turns. I will write it is a NP, primary coil turns. This is output turn. I will write NO. This is input voltage PP. Here I will use the other words. It is EB. Epsilon P it is. Then we have a formula. Epsilon is directly proportional to number of turns of the coil. Epsilon P by epsilon s equal to Np by Ns. Np value 220 volt. This is we don't know epsilon s as it is same. Np 800, Ns 8. Then let me see what we will get it here. 8 1 ja 800 ja. So 220 by epsilon s equal to 100. Epsilon s equal to 220 by 100. Epsilon s equal to 2.2 volt. This is the output voltage. The next question is, give a supply of 8 volt to ring a house bell from the 240 volt AC mains. The primary coil has 4800 turns. How many turns will be in the secondary coil? Same formula we will use. Once again, uh, this is output. This is the output. Main is equal to epsilon s output voltage. This is the input voltage, and this is primary coil rotations, number of turns of the coil, and secondary coil need to find out. Same formula will use once again. Epsilon is directly proportional to number of turns of the coil. Then epsilon p by epsilon s equal to np by ns. Epsilon p 240, epsilon s 8, number of turns in the primary coil 4800 by ns. Okay, I will use a 8 table here. 8 1 ja 830 ja 0 0 on both sides will get cancelled. Finally I have ns equal to 440 by 3, 440 by 3. Therefore ns equal to 160 turns. So in the primary coil 4800 turns, in secondary coil 160 turns. Question 4, the input and output voltages of a transformer are 220 volt and 44 volt respectively. The turns ratio, the current in the input circuit if the output current is 2 amperes. What is given? This is the input epsilon p. This is epsilon s. So need to find the turns ratio first. Same formula will use, like np by ns equal to epsilon p by epsilon s, that equal to 220 by 44. So what will you get it now? What will you get? I will use 11 table. What I will get? 1120 ja 11 4 ja, that is 2 1 ja 4 1 ja 4 5 ja. Get here 5 by 1 to say that ratio of the turns of the coil nb by ns 5 to 1. Then need to find the current here. the output current given. So the output current, so I will write it is I/O, output current. I need to find the input current. So we have a formula that it is epsilon is inversely proportional to the current. From this I will write epsilon yes I is equal to epsilon p, and this is IP. Epsilon s is 44, output current is 2, equal to 220 into IP. Then input current equal to 88 by 220. 11 table 11 8 ja 1120 ja, 4 2 ja 4 5 ja. IP equal to current in the primary coil equal to 2 by 5. 2 by 5 equal to 0.4 ampere. The last question: a student in the laboratory wants to light a bulb of 60 watt 11-volt rating with a supply of 220 volt. Mention the kind of transformer he should use. Also calculate the turns ratio for the transformer recommended by you. First, I says here the voltage is decreased from 11 to, so voltage 11 volt to, or 11 volt. Supply is given here 220 volt to 11 volt. Then this is step down transformer. Step down, it is step down, step down transformer. And what we need to find? The ratio of the turns of the coil. The ratio of turns of the coil need to find out. So same formula we can use. How many formulas till now we have taken? The same formula once again we will use to find the value of it. So epsilon is directly proportional to turns of the coil. Epsilon is directly proportional to turns of the coil. Then epsilon p epsilon p epsilon p by epsilon s equal to np by ns. np by ns equal to epsilon p is 220, output is 1, I mean 11. So 11 1 ja 11 20 ja. Therefore the ratio of the turns of the coil is np by ns equal to p by 1, I mean 20 is to 1. Thank you. So finally we have done the all numericals from electricity 3 chapters. In the coming class we plan to start 4th chapter. Bye bye, take care of you.